Alright, in the previous video, we looked at how to run your first CFD simulation. Alright, and the problem that we talked about was a simple lid-driven cavity case. If you remember, it was a 2D cavity, and in this 2D cavity the top wall was moving. Now, taking a step ahead, I want to talk about how to modify the blockMesh file. So for instance, in this case, you decide to add a small obstacle. Then how do you modify or edit the blockMesh file? So today we'll be primarily talking about the blockMesh file. All right. So let us first discuss, or let me expand this in fact. First, let us talk about the various strategies that we'll use to generate this mesh. As I said, we are thinking of adding a small obstacle inside, a square obstacle. Say if this is 1 by 1, let us add an obstacle of 0.2 by 0.2. Alright, so if suppose we decide to do this, how do we now split this mesh? Remember, we require 4 plus 4, 8 points to draw the block. 4 on the front and 4 on the rear. So in this case, there are multiple ways I could, divide this, or I could generate blocks. Or rather, a simple solution or an elegant solution that comes to mind is simply connect these lines. If we do that, we have 1, 2, 3, and 4. 4 points on the front, 4 points on the rear. We're good to go. However, there is an inherent problem in this approach. You see, these will be the region where the mesh may experience a lot of skewness. I could draw it and show it to you, but then I want to save some time, and let us directly go with a different approach. What is the approach? The idea is to divide the mesh into even smaller blocks like this, where we have added this obstacle, and now we have even split this into smaller blocks, which makes handling the mesh pretty easy. Remember, we had created points like these earlier. All right, and now what I will do is add 2 points in between. This would be located at 0.2, 0, 0 and point tell me, or think about it. What should be the answer? If suppose we decide this to be 0.2 and this to be 0.2, should this be 0.2? No, you're right. This is not supposed to be 0.2. This is supposed to be, if you divide this is 0.1, this is 0.1, and this is overall 0.5, so it is 0.4. Yes, you're right. So we've got 0.4 and then 0.6, 0, 0. Obviously, these changes need to be applied here as well. So we'll have 1 comma 0.4 comma 0. We have 1 comma 0.6 comma 0. Likewise, here would be having 0 0.60 and 0 0.40. Remember the scale option earlier that we talked about, scale option in the last video. You can in fact make this 4 and 6 and the 10 and make the scale 0.1 simply, so that while defining it would be very easy for you, or you could go this way as well. It's up to you. All right, now let's do this. Let's define this. And obviously, needless to say, the same number of points will define by adding 0.1 into the z direction, so that we define the rear points as well. And the sequence in which we define these points, we'll have to number them. So let us decide a strategy. I call this 0, 1, 2, 3. And then we have got 4. Remember, this is a point as well. 4, 5, 6, 7. Got 8, 9, 10, 11. We've got 12, 13, 14, and 15. So we got 16 points in the front, 16 points in the back. Let's do this. So now, what I do is, and another reminder is that whenever you're defining a file and you want to retain the original file, you simply add some extension to it so that OpenFOAM does not recognize that as a file and the file is still there in case you mess up. So let us open blockMesh ticked and start defining those points one by one, keeping this as a reference. So we have 0, 0, 0, it's there. Then the next point, instead of 1, 0, 0, what do we have? We have 0.4, 0, and 0. I think I'll speed this up so that you save time. So let's quickly replace this with 0.1. And we have this as well. Now when you reach this point, as a new user, you may want to do yourself a favor, and you can also decide to number these by adding comments, so that you remember which point is which, and it will be easy for you. So you could do this as well. Now we have defined all the points. We're good to go. Let us start drawing the blocks. All right. So what should be the first block? Remember, we are going to adopt an anti-clockwise approach. So I would have 0, 1, 5, and 4. All right. I have 0, 1, 5, and 4. And what I'm going to add? 16. So we've got 16, 17, 21, 20. All right. The number of divisions for now, I keep 1 across 1. Let us decide on that later. So I'll add more blocks. How many blocks do we need? We need block number 1, or let me choose a different color. We need a block number 1, block number 2, 3, 4, 5, 6, 7, and 8 blocks. In fact, what I can even do is automate this. So my block numbering starts from 1, this plus 1, let me zoom this, and this plus 16, my bad, so 0, 1, I got 4, so this plus 4, and this plus 4, and overall this plus 16. So got 4 more numbers like this, and then all this copied here. This will increment by 4, and I'll continue to do this. My bad, this has to increment by 1 for now. Yeah, so let us focus on that. Yeah, they should do it. So in fact I can copy this, and 3, there is nothing called as a 3, so I'll stop here, and then this plus 4 is the thing. This I'll paste here, and this will come here. So yes, in fact I'm going right, and simply I'll copy this, and I think I'm good now. Yeah, I'm done. So this I'll copy it here, and what I'll do is I'll do this and replace the new line with this, and here /n. And replace all, and I'll simply add this here, remove this, and voila, I have defined all the blocks. Here I'll have to remove one particular block, which is this, which represents my obstacle. To check if I'm going right, remember we had decided to uncomment, or rather comment all the boundaries and run the blockMesh command. Where do we run the blockMesh command? 0, constant, and system. At this location I'll run blockMesh. Yes, in fact the blockMesh runs fine. I'll visualize my results to see if I'm doing right. In fact, yes, perfect, I'm done. So all the blocks have been defined well. Now let us define the boundaries. In fact, I can even keep the same, but now I will have to make a little changes. Obviously in the moving ball case, I have got 3 small patches. Just have a look here. I've got 3 small patches. These patches, I'll have to define it or include it. How do we do this? Very simple. For this as well I can use calc, LibreOffice calc, but since the number of walls are less, I'll keep it to that. So 12, we've got 13 plus 16, so we got 29, we got 28. Simple. Now, similarly, we'll add 2 more pieces. We have 13, 14, and we have 30, 29. Then we have 14 and 15, and then we have 31, 30. So top wall done. For the other walls, yes, I can use LibreOffice Calc. That will simplify my work a lot. So obviously we have the bottom wall, so I'll keep that. We've got 0. All right, and obviously this plus 1, and this plus 16, and this plus 16. All right, and this goes on 3 times. So these are the 3 bottom wall patches. Then over the left wall, 0, 4, 4, 8, 8, 12. So 0, 4, 4, 8, and 8, 12. I think this I can automate. This I'll write down 0, 4, 4, 8 and 8, 12. All right, and then the right ones. So again here I'll just copy 8. I'll write 3, 7, 7, 11 and 11 and 15. Done. So simply again I'll copy it here. I'll have to replace the new line with simply a bracket here, new line, another bracket, and we're done. So these are all included in the fixed walls. These are all included in the fixed walls. Done. My pad. So we have done this. Again, here I will decide to omit this and I'll simply move on. Before I forget, moving wall, fixed wall, we need to define another patch, which is the obstacle. Now I may choose to define it separately, right? If at all I have to assign some different boundary condition there, but since here we are studying only flow, and in fact I'm going to apply no slip there as well, so I may very well include it in the fixed walls. So I need to include 4 more here. I need to include 4 more here. What are those? 5, 6. Okay. And then we got 6, 10. 6, 10. We got 10 and 9. And we've got 9 and 5. So 9 and 5. I think we're good here. Same drill again. Replace all. And I'll add those over here. I think I'm good. Now, to check if everything is right, what we will do is that we'll run blockMesh. Yes, in fact, everything is right. I can check if I have defined the boundaries perfectly by using ParaView. Here, as you can see, I can uncheck this and then I can check the fixed wall patch, and in fact, yes. And what about moving wall? Yes, perfect. So that means, and you can see groove empty has been created automatically. If I uncheck this, you can see the front and back are automatically defined empty. All right. So now let us talk about the number of divisions. For now, I'm going to use a uniform mesh. Let us go ahead with maybe 30, 20, and 30, or 40, 20, 40. So 100, or 20, 10, 20, 50. So, yeah, I think that should do it. So let us do that. So if we talk about the first block or the zeroth block, so let me define it here. 20 cross 20, 20 cross 10, 20 cross 20, 20, 10, 20, 10. Then we have 20, 20, 20, 20, 20, 10. Okay. Let me check. Okay. So now see, I did make a mistake. I think, let me have a check. But now is a beautiful part. Subdivision mismatch between phase 1 of block 0 and phase 0 of block 1. So which is block 0? This. Which is block 1? This. So block 0 and block 1. There is a mismatch. Let us check. So in the x direction we have given, if we look at the picture, in the x direction we have given 20 divisions, and in the y direction we have given 20 here. So in that case, it should be 20 everywhere. My bad. Because the number of divisions have to be the same everywhere. So that is the mistake that I made. Now blockMesh should run. Yes, perfectly fine. Let us wave the number of divisions. Surface with edges. Yes, perfect. Now here I have in fact given more number of divisions. I guess I should make it 10. Yes. So now we will have uniform mesh everywhere, so that there is no mesh discontinuity. I should not say that. The smooth distribution of elements everywhere. Perfect. So let us run IcoFoam. It runs perfectly fine. As the simulation runs, or it has completed, let us open parafoam. You can also view the results as the simulation runs, so that is also fine. And as you can see now, the obstacle or the effect of obstacle is apparent. Let us plot the streamlines, reduce the resolution a little bit, maybe add a little more number of lines. Yes, or even maybe 100. Yes, you can even change the axis. And as you can see, if I play it out, the presence of obstacle is apparent. All right. So in this video, we looked at how to edit the blockMesh file and how to modify it so that you can maybe add an obstacle, create multiple blocks, have a very smooth uniform mesh. In the next video, we would be taking a step ahead and seeing how to generate a non-uniform mesh. Stay tuned. Thank you.